Exercise 7E, question number 12. A loom makes tablecloth with an average thickness of 2.5 millimeters. The thickness T millimeters can be modeled using a normal distribution. Given that 65% of tablecloths are less than 2.5 millimeters thick, find the standard deviation of the thickness. So, first of all, the thickness T can be modeled using a normal distribution. So, we will write this. The thickness T can be modeled using a normal distribution. We know that our mean is 2.5. As it has been mentioned, average is 2.5. Standard deviation is unknown, and that is what we need to find. The information given in part 1, part A of the question, also says that 65% of the tablecloths are less than 2.5 millimeters thick. So if we put this information on the bell curve, when it is saying that 65% are less than, so less than is always to the left. So this is 65% probability, 0.65 to the left of 2.55, and this is the mean, which is 2.5. So in order to find the standard deviation, we need the z value. We can find the z value which has a probability of 0.65 to its left. So we can refer to the table to find the z value against a probability of 0.65. So we have here probability of 0.6480, 6517. We do not have the exact probability of 0.65. So here I choose to use the calculator, and this is the Casio ClassWiz calculator, which helps us to find the z value against a given probability. So first we go to menu. From menu we go to option 7, which is distribution, and after that we go to option 3, which is inverse normal. We get the option area. Area is the probability, so 0.65 is the area. Standard deviation is 1, as I am mapping this onto a standard normal distribution curve, and mean is 0. So the z value corresponding is 0.38532. Since I already have the z value, I can find the standard deviation. There is the formula that connects z value to standard deviation. Z value is equal to observed value minus the mean divided by the standard deviation. So 0.38532 is equal to 2.55 minus 2.5 divided by the standard deviation. We can work out the value of standard deviation, and we get answer as 0.1298, and that answers for the part A of the question. Now we move on to part B. So in part B, the question says we need to find the proportion of tablecloths with the thickness between 2.4 and 2.6 millimeters. So again, if we represent this information on the bell curve, we know that our mean is 2.5 and 2.4 is to the left and 2.6 is to the right. We need to observe here that 2.4 and 2.6 are the same distance above and below mean. So now we can find the corresponding z value against the reading 2.6. So we have the formula z value is equal to observed value, which is 2.6, minus the mean divided by the standard deviation, which is 0.1298, and we get the z value as 0.7704. So we have the z value. Now we can find the probability that corresponds to the z value, which means if we find the probability against this z value 0.7704, we get the probability from this end all the way up to the left tail. So this is the probability that we will find. Let us refer to the table. 0.7704, we need the probability. So so 0.7704, this is the z value, so we will check the z value of 77. So it's here 77, and the corresponding probability is 0.7794. This is the probability. So probability of this part, all of it is 0.7794. Now if we understand that from the mean up till the left tail the probability is 0.5, we can find the probability of this area by subtracting 0.5 from 0.7794. So we will do that. From the probability that we have just found, which is 0.7794, we subtract 0.5 and we get 0.2794. So we have found the probability of this part, which I am marking with the cross. We need the probability from 2.4 up till 2.6, and we know that the probability from 2.4 up till 2.6 is double of the probability of this part, as this area is evenly below and above the mean. So all we need to do is to multiply the probability 0.2794 into 2, which gives us 0.5588, which is the probability from 2.4 to 2.6. And that answers for the part B. Now we move on to the part C of the question. Part C says that a tablecloth can be sold if the thickness is between 2.4 and 2.6 millimeters. Now we need to keep in mind that we already have the probability between 2.4 and 2.6 millimeters. A sample of 20 tablecloths is taken. Find the probability that at least 15 tablecloths can be sold. Now when we say at least 15, that means 15 or 16 or 17 or 18 or 19 or 20. That's a lot of probability to calculate, and to calculate it manually it's very difficult. So now we will be using calculator, but on the calculator we will find the probability of what we do not require. So we want the probability of at least 15 tablecloth being sold, so which is 15 onwards till 20. So first we will find the probability of 14 from 1 to 14 tablecloths. So we are going to use binomial distribution here. So we can write x is distributed binomially and the total number of events is 20. Probability of success is 0.5581. We can do this using the Casio ClassWiz calculator. Now how do we do this? We go to the menu, and from menu we go to option 7, which is distribution. So once we go to option 7, then we have the screen with options 1, 2, 3, 4. but we don't want any of these options. We scroll down and we see another screen with options 1, 2, 3. We choose the option 1, which is binomial cumulative distribution, which is written as binomial CD. So I'm choosing option 1 here. After that, I see another screen with two options, list and variable. So variable is where I want to go, which is option 2. So it will give me a screen which has X. So X is the first 14, and then it has N. N is 20 events, and the last one is probability of success, which is 0.5581. So I'm going to enter all this. X is 14 and number is 20, and probability of success is 0.5588. It's 88. So that is equal to, now I get the probability of choosing the first 14 here, which is direct from calculator 0.93534, and so on and so forth. Now this is the probability of what I do not want. So I'm going to do 1 minus 0.93534. So 1 minus 0.93534, which is 0.0666. So if I want to round this off to three decimal places, it's going to be 0.065, which is the right answer. Now the C part of the question could have been worked manually also, but it would be very, very tedious. And since we are allowed to use calculator, we can use calculator to do the C part.